And I'm starting back on number 6 on the sheet that was due today that we talked about in class the other day that was kind of confusing. Let me get my color. Alright, so I'm starting back on number 6 on the one we did in class the other day about waters pumped out of the holding tank. And we started with an initial amount of 1,000 liters in the tank. So by the way it's worded, what I really should have done, really we could have done it the way we did it, but we'd have to be careful. I would say my initial amount is 1,000 minus the summation of the amount that was pumped out. Like this. And I would just say my initial amount minus from 0 to 60, this gives me amount that I lost to get the answer that we talked about that was given on the sheet. That was, what was it, 241.636 liters. Alright, so moving on, let's go to number 8. So we have the integral from 0 to 5 of f of x dx is given to us as 4. And so A, if we have the integral from 0 to 5 of f of x plus 2, I would distribute from 0 to 5 of f of x plus 2. So I would distribute this integral symbol. And this part is 4. The antiderivative of 2 is 2x from 0 to 5. So that gives me 4 plus 10 minus 0. So we get 14. On the B part of number 8, we have the integral from negative 2 to 3 of f of x plus 2 dx. This one's really important to listen to. I'm going to let u be x plus 2, du is dx, because it would just be 1. And now I'm going to go into substitution. So this gives me f of x plus 2, which is f of u. Dx is the same thing as du. And my new limits of integration. If I fill in negative 2 right here, u is 0. If I fill in 3 right here, u is 5. And so according to this, it doesn't really matter if the variable changes, if this function from 0 to 5 would equal 4. And so you may wonder why on the B part they had 4, but we needed a substitution for that. C, if I'm going from negative 5 to 5 of f of x dx, if it's even, like we talked about in class today, I could double it from 0 to 5. We don't know what the function looks like, but if it's evenly dispersed over the axis, like whatever happens here also happens here. And so I could double my answer. So I have 2 times 4, which is 8. And D, if it's odd, the answer was 0, because if you go from something that's odd and you go from negative 5 to 5, it cancels out, and your answer is 0. Number 9. Sorry, it's not working. All right, so number 9. We have used the figure at the right. All right, so we have this figure. It's very geometric looking. And this is 1, 2, 3, 4, 5. Of course, there's a better one on your sheet. We're given p of 0 is 2, and this is dp dt. Or in other words, the derivative of p, apparently with respect to time. So this is t instead of x along the horizontal axis. Okay, so, and this is negative 1 to 1. All right, p of 0, and if I want to integrate p prime, so I'm going to say the integral of p prime dt, I'm going to use 0, and the first thing I need to find is when t is 1, So I'm going to go from 0 to 1. Now by the first fundamental theorem of calculus, integrating p prime will take me to p of 1 minus p of 0. Now I'm going to calculate this from 0 to 1, and the answer is obviously negative 1. Right, now they told me p of 0 was 2, so now I know p of 1. If I add 2 to the other side, I get p of 1 is 1. All right, now I'm going to find when t is 2. So I'm going to go from 0 to 2, p prime dt. Fundamental theorem of calculus gives me p of 2 minus p of 0. And from 0 to 2, you get negative 2. P of 2 is what we're looking for. P of 0 is 2. And so these cancel out. So when you add 2 to the other side, you get p of 2 is 0. For t equals 3, I have the integral from 0 to 3 of dp dt, or p prime. And so now I'm going to go all the way to 3. And I believe that gives me negative 2.5. Oh, I'm sorry, I'll write that in a minute. I always just write out all of the algebra first. This means to me p of 3 minus p of 0. Then I figured this out as negative 2.5, p of 3 minus 2. So p of 3 is negative 1/2. Negative 0.5. All right, and then p of 4. So you were seeing we can find all of these literal points. P prime or dp dt, fundamental p of 4 minus p of 0. Now I'm going to figure this out from 0 to 4. And these cancel each other out, and so I'm back to negative 2. So this is negative 2. So that didn't work. Negative 2 equals p of 4 minus p of 0, which is 2. And so p of 4 is also 0. I'm not sure why this isn't behaving. Let's see. All right, and then p of 5. P of 5, I'm going to go from 0 to 5 of p prime dt, and that gives me p of 5 minus p of 0. So if I go all the way to 5, these parts cancel out, and I just get negative 1. So p of 5 is 1. All right, so that is number 9. All right, number 10. We have this picture from 1 to 2, 2 to 6, and 6 to 8. All right, and they tell me this is 2, this is 7, and this is 4. All right, and we are told that this is f prime. So, and we know f of 2 is 3. And so we're going to use the figure at the right to sketch the graph of f of x and label at least 4 points. So always label your graph. This is f of x. We know that we have the point 2, 3. Okay, so I'm going to find f of 0. So I'm going to go 0, 2, 2 of f prime of x dx, and spell out my algebra by the fundamental theorem of calculus gives me f of 2 minus f of 0. I know from 0 to 2 that this is positive 2, and f of 2 is 3 minus f of 0. So I know f of 0, capital F, is 1. So I have the point 0, 1. All right, and then I thought I would find f of 6. So I went from 0 to 6, or no, I'm going to go from 2 to 6 because this is a given. So I'm going to go from 2 to 6 of f prime of x dx gives me f of 6 minus f of 2. And this is 2 to 6 is negative 7. F of 6 I'm looking for, f of 2 is 3. So f of 6 is negative 4. Let's see, 3, 1, 2, 3, 4, 5, 6, negative 4. All right, and then I'm going to integrate from 2 to 8 of f prime of x dx, still using the 2, the given, is f of 8 minus f of 2. And if I go from 2 to 8, this is, I think that was 7. Yeah, so this is 7, and this is 4. And so if I keep a running total, it's negative 7 plus 4, or negative 3. Equals f of 8 minus f of 2, which is 3. So f of 8 equals 0. So I have 1, 2, 3, 4 points. F of 8 is 0. All right, which is what I think you have. They found 1, they found negative 4, and they also found 0 is all you saw, but you couldn't really check your graph. Now I'm also going to merge that with a first derivative chart. Okay. Looking at the first derivative from 0 to 8. My first derivative is 0 at 2. It is 0 at 6. It's positive before, negative between 2 and 6, and positive after. So that means my function is increasing, decreasing, increasing. I think it looks like this: increasing to 2, decreasing, increasing. But, you know, maybe we don't really know if it's not that curvy. So I can also find something else about it with a second derivative test. So let's take the derivative of the picture that they gave me, because I've talked a lot about we ought to be able to go back and forth between the two. This looks like it has a horizontal tangent at 1, and looking at your paper, it looks like it's a horizontal tangent around 4. Looks like about 4.1 really, just estimating. And we have another horizontal tangent that looks like it's 7. So we're talking about what this is doing. Leveling off tells me what its derivative. What this is doing tells me what its derivative is. While this is increasing, the derivative should be positive. While this is decreasing, the derivative should be negative. While this is increasing to 7, the slope should be positive, and then negative. That tells me all the way back about f is concave up, concave down, concave up, concave down. And so this graph is, oh, it should be concave up from 0 to 1. But I know I have 0 tangent, so somehow it's gonna, oh, I'm sorry. Okay, so from 0 to 1, I have a little bit of concave up, and then from 1 to about 4.1, it's concave down. So far it's kind of going like this. And then from 4.1 to 7, to right, let's see, this is 1, 2, 3, 4, 5, 6, 7. It's concave up, so it's going like this. Concave up until I get to 7. And then I have a concave downward turn. So it's got a little more drama to it than originally. So it goes concave up, and concave down until I get to 4.1, and then concave up, and then I have a little bit of concave down. Because this is decreasing, its derivative is negative. So that means I would have to have some concave down going on. And I should stop it, though, at 8, 0, sorry. So it's subtle concave down right there. All right, now let's go to number so number 11. All right, on 11 we have use the figure at the right, and the figure at the right is g of t. And it goes to 2, and then to 4, and then to 5. And this is 16, 8, and 2. All right, use a figure at the right to sketch the graph of antiderivatives of g of t. And we know g of 0 equals 5. And we'll label each critical point with its coordinates. Let's see what kind of answer you've got there. Whatever 21, 13, and 15 are. So we'll visit where they got these numbers. The question's worded kind of funny. Using the figure at the right, sketch the graph of the antiderivatives g of t of g of t. Okay, so what they're telling us, g of t is the derivative of g, like this. So if I integrate g of t, that's like integrating the derivative of that, which will take me to this from a to b. Okay. So again, it's worded kind of weird, but the graph of the antiderivatives g of t satisfying g of 0 equals 5. On the test, it would have to be worded a little bit better than that. But I'm going to integrate little g, which is the derivative of big G. So the antiderivative of g of t will go from 0 to 2. That would take me back to capital G from 0 to 2. So that'll take me to g of 2 minus g of 0. All right, from 0 to 2 is 16. G of 2 we're looking for. G of 0 is 5. So G of 2 is 21. That's where we got this. All right, I'm going to stay with 0. So I'm going to go from 0 to 4 of little g, which they didn't tell me very well, but it's the derivative of capital G from 0 to 4. So that gives me g of 4 minus g of 0, first fundamental theorem of calculus. All right, so this is 16, and this is 8. Running total will leave me with 8. G of 4, g of 0 is 5. So g of 4 I'll get it in a minute, sorry. G of 0 is 5. So g of 4 is 13. That's what this is. Then I'm going to go from 0 to 5 of little g. Will take me to capital G of 5 minus g of 0. Writing's terrible. So you have 16 minus 8 plus 2, and so that gives you 10. G of 5. G of 0 was 5. So G of 5 is 15. So that's where they got that number they were trying to tell you. So now we're going to sketch the graph of G of t. All right, so we have 2, 21, so I'm going to go 5, 10, 15, 20. And G of 0 is 5. G of 2 is 21. G of 4 is 13, 5, 10, about right here. And G of 5 was 15. So a little bit up. This derivative goes positive, negative, positive. So we know it's some form of increasing, decreasing, increasing. But we can also do a second derivative chart on this. Okay, to be a little more clear. G is G prime, so I'm looking at G double prime from 0 to 5. Looks like G prime would have a horizontal tangent at 1 and right in there at 3 and at 4.5. This is increasing, and so the slope would be positive, while this is decreasing. G prime's derivative would be negative. This is increasing, and this is decreasing. So we definitely have points of inflection in there because of the sign change. So I've got a little concave up again from 0 to 1, and we don't know G of 1. We never found it, I don't think, but we'll do a little concave up, and then from 1 to 3, it's concave down, wherever 3 is. And then between 3 and 4.5, it's concave up, and 4.5, and then we have a little bit of concave down here at the end. So it goes like concave up, concave down, concave up, and there's just a little tail there that's concave down, going from 13 to 15. All right, I'll stop there. Oh, let's see, how much more do I have? Yeah, I'll go in and finish this page, and then I'll make another video, so it's just shortened videos. All right, so this is number 12. Number 12. Alright, so number 12, find the value of f of 1. You have f prime of x is equal to e to the negative x squared, and we know f of 0 is 2. I don't know if you knew this, but I can tell this is a calculator active problem. Even when we get really good at these, we're still not going to be able to do the antiderivative of that. So get out your calculator and go from 0, because it's given, to 1, because you're looking for it, of e to the negative x squared, which is f prime of x. And if you integrate that, that'll take you to the antiderivative of f of 1 minus f of 0. And so you find this value, and actually it looks like the calculator's not working on this screen, so I don't know what you get. I can punch it into this calculator. Alright, so I'm going math 9 from 0 to 1 of e to the negative x squared dx. And that value gives me 0.7468, 0.7468, so 7, equals f of 1 we're looking for. F of 0 is 2. So let's see, on our answer sheet, number 12 should give you 2.747, which is what they have. All right, number 13, I've had some questions about. F of x is equal to 2x and 2. X is less than or equal to 1. X is greater than 1. We want to evaluate it from 1/2 to 5. F of x dx. Well, there's two different things during this time frame from 1/2 to 5. So I'm going to break it up and go from 1/2 to 1, because it says when x is less than 1, f of x is 2x. Then I'm going to continue on to 5. So from 1 to 5, during the time I'm greater than 1, f of x is 2. So I have to integrate it as a piecewise function. Antiderivative of this first part is 2x squared over 2, or just x squared, from 1/2 to 1. So it gives me x squared is 1 squared minus 1/4. That's this part. This part gives me 2x from 1 to 5. So this part gives me 10 minus 2. So it gives me 3/4 plus 8, which I believe on the answer sheet you have 8 3/4. Okay, that's the end of this video. I'll make another video with the third page, and then another with